Record. All right, so the first topic that we're going to talk about is one called computer number systems. And what we're going to do with computer number systems is mainly converting. And all of a sudden, we're going to look at the nerdy way to do a little converting as well. What you see in front of you, some examples of what we're going to start with is how do I convert from different bases to another base? And as we know, okay, John, is anybody else having trouble with the record with my voice? No? Okay.
I can hear you just fine.
All right. So John, you may, if you lose something, I am recording. You'll be able to go back and look at the recording. So base 10, we know that includes the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Base 2 is the numbers 0 and 1. Base 5 would be the numbers 0, 1, 2, 3, 4. So if I was to count in a different base other than 10, for example, if I was counting in base 3, I would have something that looks like 0, 1, 2, and then I'm stuck. I can't go anymore. My next number, 1, 0, 1, 1, 1, 2. My next number, 2, 0, 2, 1, 2, 2. I can't go any higher here. I can't go any higher here. The next number, 1, 0, 0. So in our world of counting, in base 10, this was 0, this was 1, this was 2. This is 3, 4, 5. This is 6, 7, 8, 9. Now, what I want you to take a look at is this real quick. In our base 10, if I gave you the number 248, this is the same as 8 times 1 to the 0 power, 4 times, excuse me, not 1 to the 0 power, we're on base 10, 10 to the 0 power, 10 to the first power. This is 2 times 10 to the second power, which is 100, 2 times 100, 4 times 10, and 8 times 1. So every one of our columns in our counting system is represented by a base of 10 to a certain power. Well, if I come over here, I can almost do that the same way. If I look at these columns, this column being the, instead of 10 to the 0, okay, this was 10 to the 0, this is going to be 3 to the 0 power. The second column is going to be the 3 to the first power. The third column is going to be the 3 to the second power. So if I took any one of those numbers, like 12, that's 1, 3 to the first, right? I'm looking at this guy right here. That's 1 times 3 to the first plus 2 times 3 to the 0 power, which is 3 plus 2, which was in fact 5. So the location determines the power. 0 power, first power, second power, and so on. So we're going to keep that basic idea in mind as we go through this. All right, so I want to convert base, well, let's do this one because it's going to be similar. If I want to convert base 2 to base 10, I'm going to start with the base 2 number. 1, 0, 1, 1, 0, 1, 0, 1. Okay? Now, using that same, and when I represent it as a base 2 number, I'm going to put a little 2 down there. If there is no little number, the default is, in fact, base 10. So for this guy, I'm going to say, well, this is 1 times 2 to the 0 power. 0 times 2 to the first power. 1 times 2 to the second power. 0 times 2 to the third power. 1 times 2 to the fourth power, 1 times 2 to the fifth, 0 times 2 to the sixth, and 1 times 2 to the seventh power. I have a 1, 0, 1, 0, 1, 1, 0, 1. Okay, I'm good. 2 to the 0 power is 1. 1 times 1 is 1. 0 times anything is 0. What number is this going to give me?
4.
right? There's no 8. All right, I'm starting to get a pattern here. There's a 16, there's a 32, there's no 64, and there's a 128. So if I now proceeded to add all of these numbers together, 160, I get 181. So I was able to convert this base 2 number to a base 10 number. Okay. What if I wanted to go down here, base 8 to base 10? We're going to keep practicing this same idea. Somebody give me a 4-digit base 8 number. So all I'm asking for is 4 numbers in a row, each of the numbers less than 8.
1, 3, 4, 5.
Thank you. 1, 3, 4, 5 in base 8. I'd like that to become a base 10 number. All right. Same idea. 5 times 8 to the 0 power, 4 times 8 to the 1st. I have 3 of these 8 to the 2nd, and I have 1 of the 8 to the 3rd power. 5 times 1 is 5. I got that one for you. 4 times 8 is 32. Whoop, that's a 6. I want 32. 3 times 64, 192. 1 times 8 to the 3rd power. I'm going to cheat. That's 2 to the 3rd to the 3rd, which is 2 to the 9th, which is, I know 2 to the 10th is 1024. So this is 512. Add them up. 5 and 2 and 2, that's 9. That's 11. Carry 1. 14, carry 1. I get 741 in base 10. Anybody else? Okay. Let's see what we can do about going the other direction. What if I give you a base 10 number and I'd like to become a base 2 number? How do I go about doing that? A couple of you were in my CPS 161. Do you remember how we did this? Nope. Okay. So let's go back and we'll use that method because it's tried and true. There are other ways to do it, but I like this method because it also will lead us into a program. So I'm going to take a 2 and I'm going to divide it into 181. What do I get? How many times 2 go into 181?
90.
90. What's my remainder?
1.
1. How many times does 2 go into 90?
45.
45. What's the remainder?
0.
How many times does 2 go into 45?
22.
Remainder.
1.
2 go into 22.
11.
Remainder.
0.
2 go into 11.
5.
Remainder.
1.
2 go into 5.
2.
Remainder.
1.
2 go into 2.
1.
1. Remainder.
0.
2 go into 1.
Nothing.
Remainder.
0. 1.
1. Check this out. Check that out. 1, 0, 1, 1, 0, 1, 0, 1. Ha ha ha. So I went down the line. The good news is this is going to work out the same for over here. If I have 741 and I want to convert it to a base 8 number, I'm going to do the exact same thing. How many times does 8 go into 741?
92
92 with a
with a remainder of 5.
5. Excellent. How many times does 8 go into 92?
11 with a remainder of 4.
11 with a remainder of 4. 8 goes into 11
Once.
with a remainder of,
3.
and 8 goes into 1
Nothing.
with a remainder of
1.
1. Pop, 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 pop. 1, 3, 4, 5. Nice and easy. What do you think about that? We're good? Okay, I want to pause the recording for 1 second. Now, moving on, we're going to talk about, we get into this world of computer science and we bring in this new numbering system that becomes important to us, and that's base 16. Base 16 has its own name, hexadecimal. Okay, and hexadecimal, yeah, I want to go to base 16, and in my world I have numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, but I can't use 10 because that becomes a double digit. Okay, so now instead of a 10, I use A instead of 11, B, and so on, all the way up to F represents a 15. So if I was counting in hexadecimal, you know, I'd be going 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, 1, 0, 1, 2, 1, 3, all the way up to 1, 9, 1 A, 1 B, 1 C, 1 D, 1 E, 1 F. So let's start up here, and because it worked pretty well going the other way. And I'm going to say, I have a base 16 number, and I want to convert it to base 10. So let's use this base 16 number, A12B. And I want to convert that to base 10. Well, the pattern that we had was we're going to take B, multiply it by 16 to the 0 power, then 2, multiply it by 16 to the first, 1 times 16 to the second, and A times 16 to the third. Moving along, B, that's going to be 11 times 1. 2 times 16. 1 times 256. 10, A represents 10, times, oh boy, 4,096. 40960. Can someone confirm that for me?
Yeah, that's right. It's 4,096.
Awesome. I add all these up. 6 and 2 and 1 is a 9. 4, 9, and a 6 is a 15. 10, 11, 12, 1, 4. So it should equal 41,259. Let's go the other way. 41,259 in base 10 equals what in hexadecimal? Well, let's see. We did 41259 divided by 16. I'm gonna ask them. Hey Siri, what is 41,259 divided by 16?
41,259 divided by 16 is 2,578.6875.
2,578. Now I need that decimal part, right? What's my remainder?
I got a remainder of 11.
There's an 11. Did you, or do you already know what it's supposed to be?
No, I had my calculator has like a function where you can do remainder division.
All right, 16 goes into 2578. How many times? I know what the remainder is going to be. Ba-da-ba-ba-ba.
161.
161 with a remainder of what?
2.
2. 16 goes into 161 how many times?
10.
With a remainder of
1.
16 goes into 10 how many times?
0.
None, with a remainder of 10. And we know in our world that's A, that's B. So I'm going to write A, 1, 2, B. Nice. Got it. I love it. Do-do-do-do-do. Oh boy. So base 10 had a nice pattern going and everything for us, right? So if I wanted to convert a base 8 number to base 16 or vice versa, oh boy, how do you think we would go about doing that? Could I go from 8 to 10 and 10 to 16?
Yeah, but that takes a long time.
Well, what if I don't know another way?
I mean,
Let's
it'd
see.
work.
Let's try something simple. 127 in base 8 equals what in base 16? So that means I want to go 127 in base 8. I want to go to base 10. All right. So that was 7 times 1, 2 times 8, and 1 times 64. And that gave me 73. Did I do that right? 8 to the 0, 8 to the first, 8 to the second. 7, 16. As wait, that's not 73. I messed that up on purpose because I got sloppy. Equals 7 equals 16 equals 64. 70, 87. Do we like that a little better? Yeah. Anybody?
That looks good to me.
Okay, thank you. Now I want to go from 87 in base 10 to base 16, right? Because that was that. This was the first step to convert to 10. 10 can now go to 16. How do I do that? I do 16 goes into 87. 1, 2, 3, 4, 5 times with a excuse me, remainder of 7. That goes in 0 time. 57 in base 16. Cool. Got my answer. 127 in base 8 is 57 in base 16. Okay, so now there's an easier way. Nathan's like, there's got to be an easier way. And in fact, there is. If I took a base 8 number, okay, and I started thinking about base 8, that's the numbers 0, 1, 2, 3, 4, 5, 6, 7. How many total numbers is base 8? Well, it's a total of 8 numbers, right? And if I go into my binary world and I want to represent the numbers 0 through 7, I'm going to go, what's he saying? All right, let's see. I'm going to go 0, 1, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. That's 0, 1, 2, 3, 4, 5, 6. What I miss? Did I miss any? 0, 1, 2, 3, 4, 5, 6. I missed something. Oh,
You didn't just do one.
I know, I see that. Thank you. 0, 1. Yeah, there's 1, 2, 3, 4, 5, 6, 7. There's 8 of them. This is the numbers 0, 1, 2, 3, 4, 5, 6, 7. Okay. How many digits did I need? How many columns did I need to represent the numbers 0 to 7? I only needed 3 columns, right? 8 is 2 to the 3rd power. 16 is what? 2 to the 4th power. So if I wanted to represent the numbers 0 to 15 in base 2, I'd be going 0, 1, 1, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1, 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1, 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 1, 0, 1, 1, 1, 1, 1. All ones. 16 numbers, right? 0 to 15. So I can represent it in 4 columns, 4 places. Okay. We're getting somewhere now. All right. So I want to take a number and I'm going to do this number. Let's see. If I said turn 23 in base 8 to base 2, here's how I would do it. The 3 is going to be in the first 3 digits. Okay, the 3. How do I represent 3? That's going to be 0, 1, 1. A 2, if I want to represent that in 3 columns, 0, 1, 0. If I just thought of that, that's 0 times 1, 1 times 2, 0 times 4. So this is 1, 2, and 4 in my head. So I don't have a 1, I have a 2, I don't have a 4. I have a 1, I have a 2, I don't have a 4. So this 23 in base 8 can be written as 3 columns in base 2. And again, if I did the work the other way, you know, I was doing all of that. 2 goes into 23. And if I do 2 goes into 23, it goes in 11 times with the remainder of 1. 2 goes into 11 5 times with the remainder of 1. Am I doing something wrong here? 22 is 11, 5. 2 goes into 5. Oh, I'm doing base 10, that's why. Don't even look at that. All right, so I think I'm losing, folks. So I'm going to do it in reverse this way. I'm going to explain it a better way. Okay, so if I have 0, 1, 0, 1, 0 and 0, 1, 1 in base 2, and I said to you, what is that in base 8? Okay, the way we represent it is base 8 is 0 to 7, 0 to 7, 0 to 7, 0 to 7. So when I look at this, I'm going to take these first 3 digits and come up with a number. Okay, that's a 1, a 2, and no 4. That's a 3. The second number, a 0, a 1, and a 0. That's a 2. So when I take a base 2 number and go in groups of 3, knowing each group could represent the numbers from 0 to 7, each group could be a number from 0 to 7. Because it can be from 0 to 7, it becomes a base 8 number. So that's 23. And again, if I check this, if I made this base 10, I have a 1, a 2, and a 16. That's 19. I have 2 8s and a 3. That's also 19. So if I gave you another number, 1, 1, 0, 1, 0, 1, 1, 0, 1, and I said, convert that base 2 number to base 8, we'd use the same idea. 101, what number would that give me? A 1, no 2, and a 4. 5. I take the next 3 numbers. What does that give me? A 5 again.
5,
Yeah. And I take the next 3 numbers. What's that give me?
6.
6. So I can quickly go from base 2 to base 8 by looking at these groups of 3. And again, the groups of 3 are the numbers 0 to 7. I can go through and check the work, and I'd find that both of these are the same number if I converted them to base 10. Now, as much as 3 numbers gives me 0 to 7, 4 numbers, 1, 1, 1, 1. If I did 4 numbers, what would that be in base 2? A 1, a 2, a 4, and an 8. 15?
Yeah.
What if I gave you 0, 0, 0, 0? What would that give you?
0.
Yeah, thanks, Nathan. That's the good one. What if I gave you 1, 0, 1, 0? What would that give me?
2, 10.
No 1, a 2, no 4, and an 8. That would give me a 10, right? So by looking at these groups of 4, especially these first 2, I see I can make a number as small as 0 and as large as 15. Now we said that's 15. So if I'm converting to base 16, my 15 was an F. My 0 is a 0. This was an 8 and a 2, 10. What was 10?
A.
A. So from base 2 to base 16, I could get something that looks like A0F. All right. Very mediocre explanation. Let's move on. I now would like to convert a base 16 number to base 8. And instead of going through all of this rigmarole, I'm going to do it using, instead of base 10, base 2. Why? Well, let's see. AB1F in base 16, I want to go to base 8. Let's represent each of these as a base 2 number. What was A? A was 10. That was
1, 0, 1, 0.
1, 0, 1, 0. What would B be?
1, 0, 1, 1.
What would 1 be?
0, 0, 0, 1.
And what is F?
All ones.
Okay, so I can quickly go from 16 to base 2. There it is. And like I said, you can confirm that by going to base 10. Now, a moment ago, I said my base 8 numbers are groups of 3 coming out of binary. 1, 2, 3, slash, 1, 2, 3, slash, 1, 2, 3, slash, 1, 2, 3, slash, 1, 2, 3, slash. So coming out of this, I'm now going to have a 1, a 2. This is a 1, no 2, and a 4. So that's
5.
5. This guy is
4.
4.
4, 3, 7
7.
in base 8. So AB1F in base 16, if I go to binary, 8 is groups of 3, 16 is groups of 4. So when I rewrite this, I get 1, 2, 1, 2, 5, 4, 3, and 7. What if I went the other way? Now, one more example. 1, 0, 1, 0. Ah, you clown. I need a base 8 number. 5, 4, 3, 2, 1. In base 8 is what in hexadecimal? let's see, a 5 is a 4, no 2 and a 1. 4 would be 1, 0, 0. 3, 0, 1, 1. 0, 1, 0, 0, 0, 1. Groups of 3. Now starting on the right, a group of 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And I only have 3 left over there. 1, 0, 1 is 5. 0, 0, 0, 1. A 1, 2, 4. This is an 8. 1, 0, 1, 1. Okay. A 1, a 4, and an 8. That's 13. But instead of 13, we're going to put D. And then finally, the last one is just a 1. So 5, 8, D, 1. So the packet looks something like this. Talks about computer number system, has a whole bunch of problems, has the solutions, but we're able to go through and work some of these problems. Coming still here on this first page, this first one, base 16 to base 8, kind of what we've just been doing, right? If I have 3, 6, 7, 6 in base 8, well, they're actually asking go to base 10 and go to base 16, but we know we don't have to do that. We can go right to 16. Write these out as groups of 3, then reorganize them into groups of 4. Go ahead, let's see what you get.
It's 3676. Is that what it was again?
3676, yes.
3, 6 is zero. So 3, 7, 8, 11. That's B. And 8, 12, 12, 13. No, it's 14. 14 is E.
Seven BD. I know at least one other person got it.
I got 7BE.
14 is E. 15 is F. You are correct. I didn't have my little cheat sheet. Let's take a look at this one at the bottom. I have a base 16 minus a base 16, and I want to answer in base 16. Feed minus 6ACE. I need my A is 10, B is 11, C is 12, D is 13, E is 14, so I don't have another mistake, and F is 15. Okay, D minus E. If I convert this in my head to base 10, D is 13, E is 14. I can't subtract them. In my world, what do I have to do if I can't subtract? B word. Say borrow. Nathan.
Borrow.
Borrow, thank you. So I'm gonna borrow one from the E, which now turns E into what? D. I borrowed, and what did I bring over? Well, in our world, in base 10, I bring 10 over. But in base 16, what am I bringing over?
16.
Right? So think of this as 16 plus 13. What's 16 plus 13?
29.
29 minus 14. 29
15.
minus 14 is what?
15.
15, and 15 is F.
F.
Very good. D minus C, that's an easy one. E minus A,
4.
4.
F minus 6.
9.
Good. So I was able to do it using a pattern from base 10 with base 16 numbers. And if I have to borrow, I borrow. In base 10, we borrowed 10. In base 16, we're thinking about borrowing a 16 to add on there. Questions? Coming over to the next page, we have a whole bunch of problems. What do you think? You see one in there that looks pretty good or hard or would be a good place to start? Number 3, the answer is 1. I don't know why 39 is put there. So that's already a mistake. We know that. That's a 1. Anybody pick a problem? Pick a number. Or do you think you got it? We have 7 minutes. Pick a number.
7.
I heard a 7. I heard a 7. Okay. So I'm going to write it on some scratch paper so I can scratch away. Number 7 is F, A, D, oh boy, E, D, A, C, E in base 16 minus F, E, E, D, C, A, F, E plus A, D, D, E, D, all in base 16. I start scratching my head and I'm thinking about doing this, but I think this number might be bigger than this number. So, okay, might have to be careful with this. But I also know the commutative property in this world exists. And I could actually, if I had this problem, 6 minus 8 plus 4, what would you do first? Well, you're okay with making this a negative number, correct? And going from there. Could I also add the 4 to 6 first? Okay, so maybe I want to start by saying, what if I take faded ace and added to it? Because I'm allowed to do that. A is 10, B is 11, C is 12. I'm adding these two, right? D plus E. $13 and $14. Sir, that's 27. You are right. But 27 is bigger than 16. So I'm going to change 27 into a 16 and a 11 so that I can carry 1 and this becomes just B. Oh, what is 1 plus C plus E? 1 plus 12 plus 14 is
B carry over the 1.
it's another 27. B carry over the 1. What is 1 plus A plus D?
8 carry 1.
8 carry a 1. What is 1 plus D plus D?
B carry a 1 again.
Another B carry a 1. What is 1 plus E plus A?
Nine carry 1.
9 carry a 1. D plus 1,
E.
E, A, F. So now I have F, A, E, 9B, 8BB minus feed cafe. Well, that didn't seem to help so much because my second number is bigger. Okay, that's fine. I know my answer is going to have to be a what? A negative, right? Okay, so I'm knowing my answer is going to be a negative. I can put the bigger number on top. And instead of 6 minus 8 being -2, I could do 8, subtract 6, and know my answer is a negative. So I'm going to be able to do feed cafe minus FAE 9B8BB. And when I subtract, I know my final answer has to be a negative. E minus B.
Three.
F minus B.
4.
A minus 8.
2.
C minus B.
1.
D minus 9.
4.
E minus E.
0.
E minus A. How about that?
4.
Didn't have to do any borrowing. So my answer should be -4041243. And when I look at the answer sheet, whoop, whoop, I see it's the right answer. Okay, so there are more problems on there for you to practice. The syllabus actually points out the date of when the selected topics quiz will be, but you can work on these problems at any time. At the start of class, you can say, hey, I have a question about number 1 from the blah, blah, blah topics, and I'll take those at the beginning of class or by way of email. But you'll have 2 computer number system problems on the selected topic quiz.